Welcome back to the second edition of 2023 to the Rust Munich Meetup. Today we have quite a few of talks, 4 to be exact. We're going to be starting with Marco, but before we dive into the talks, first we want to give the audience a second to get to know our host today. Mm-hmm.
Hi. So good that you're all here. Good evening. Maybe let's start with the organizational stuff. And one thing is really important. This door over there is the toilet. It doesn't have a key. So if you go in, you turn like this thingy around till it's red and says in German besetzt. If you come out, also really important, turn it back to green, right? Because if not, all the others are going to wait, thinking there's someone in there, and there's nobody in there. And then maybe after an hour, open the door, and then there's still someone in there. So yeah, maybe it's one organizational thing that's important to say in the beginning. I think everyone already saw the food and drinks, so feel free and have a good time. Maybe before we jump in, my name is Sarah. I think I talked to most of you already. I'm with Main Matter since 1.5 years. I'm in charge for business development. I'm not a developer, so please excuse if I'm asking stupid questions, which happens sometimes, being a sociologist. All right, but a short introduction to who Main Matter actually is. We are, this doesn't work, okay, good. That's the sociologist who didn't understand it. Maybe you also should connect to the beamer. Somehow no signal. Okay, it's actually also not that important. But I have to stay here because it's kind of hard, right? So basically what we're doing, we are building web apps. And we have several clients around all Europe, helping them to develop their products. We either do that fully or we augment their team, which is for us a really nice approach, as then we can also mentor them by doing pair programming, and we're also offering quite a few workshops. So if some of you are beginners in Rust, you can also book a Rust workshop with us, for example. Good. That's something I already presented. Yeah. So why Main Matter and why Rust? We think Rust is a really nice language. Our team has the open source thingy in the DNA. So one thing before, you may ask yourself, why this little office and why so cozy? We are more than 20 people and we're a fully remote company. We're in, I think, 10 different countries or 12.
Something like that. From Portugal to Hungary.
Yeah, kind of from
UK or Ireland
to Italy, kind of.
Italy.
Yeah, so we're pretty diverse in that sense, and it's a wonderful team. And each of the team members has like 20% of their time also to work on open source topics, and that's also why it's important for us to kind of be part of the Rust Foundation, for example, to make it possible for our team to contribute to open source. We do that also for the Rust projects. And that's why it's also important for us to play a role, at least, to foster communities. That's why we're organizing, for example, AmberFest, but something which is much more important is that we're the organizers of Eurorust. And who of you knows Eurorust? And who has tickets for the next Eurorust? Can you do the pitch why everyone should come to Eurorust, please?
It's a great conference. I went to the conference last year in Berlin, and it was a lot of great people and good talks and good food and great opportunity to meet other people in the Rust community.
So you would recommend it, right?
Yeah.
Yeah.
I'm going again.
Good. I also recommend it. So if you don't have a ticket yet, please get a ticket. It's a 2 days conference. This year we're going to be in Brussels. We have an amazing location. There's going to be a lot of waffles. There's also good beer. And there's going to be amazing Rust talks. Speaking about the Rust talks, the CFP is open. So please feel free, if you have something in mind, to submit a talk. CFP is still open around 2 months. So go ahead, get a ticket, submit a talk. Let's party in October together in Brussels. And now have a beautiful evening and enjoy the talks. We have 4 talks today. The first one is going to be Marco.
Yeah.
Und wie machen wir das jetzt? Schließe ich das?
Die Slides da. Hast du deine Slides da?
Ja.
Yeah.
Und
Fullscreen. Und ich kann die Slides hier
du machst weiter. Okay.
Wir würden noch die eine Slide finden.
So I can use Keynote then?
Yes.
Could I extend the screen instead of mirroring, or does that break all the?
Should work.
Yeah. Because then I can see my notes and I don't forget 50% of what I wanted to talk about.
Yeah. But before we start, we have a bunch of new equipment, and so we now also have sponsors for our equipment that deserve a slide. So yeah, like the sponsor for our new microphones is going to be TechnaSearch. TechnaSearch is a agency or headhunter company. Correct me if I'm wrong, guys. Providing services around any kind of Rust, Rust jobs in different areas: cryptography, hardware, firmware, and backend development. Yeah, if you are interested in a full-time Rust position, then please reach out to these guys. Wave again.
Okay, so the sociology thing.
No, 1 second. Otherwise, we just do it differently.
I think the day humanity figures out a convenient way to do presentations.
Will that be before we have reliable printers or afterwards?
And this is presentation mode doesn't work. Let me change it. Then we just do it like oops. Okay, good. So I don't have my notes, but I maybe remember some of the things that I want to say. So I wanted to talk about sending emails from the edge with Rust. And let me maybe use my phone here to see my speaker notes, because that should work as well. Yeah, so my name is Marco. I'm the founder of Main Meta. As Sarah said, we do like web engineering and a lot of mentoring for teams that do web engineering and that build web apps, and then we help them sort of build better web apps in a better way. And last year we made a bet on Rust as a company. Like, we think there's a lot of potential for us in the area that we work in, right? For like web and cloud-based applications, backends. Maybe not as a replacement for like Rails or Node app or so, but maybe a microservice environment, maybe proxy services, maybe upstream services, all kinds of things that are maybe not as obvious for us, but that still have can benefit from Rust substantially. And today I want to talk about something that I did recently with Rust, which is implementing submission for a contact form on the website. So the website is entirely static. It's served as like static HTML files and images and so on from Netlify. So when someone like wants to submit a contact form, there's no, like, we don't have a server there where we can accept the request, right? So we need to have some sort of server elsewhere where we can send that submission and then send the email. We used to have like some AWS Lambda, like a node thing running on Lambda, but like the deployment didn't work anymore. It was like based on like super outdated Lambda runtime that was about to be shut off. So we had to redo it, right? So we thought, why not do it in Rust, right? And then run it on an edge server for minimal latency. So it would be super fast, right? And it would be fast because of Rust anyway, because Rust is fast, right? Because all of the typical services, sort of that offer edge computing, support running Rust now, right? Like Netlify, Fastly, Cloudflare, so they all have offerings for running edge functions they can run in Rust. Right? And essentially what they all do, they just run V8 on these edge functions, and V8 supports WebAssembly, so you can write in Rust, compile to WebAssembly, and then run it on those edge functions, right? But there's obviously still a JavaScript wrapper, as you would have in the browser, right? That loads the WebAssembly, runs it, and then responds with whatever that WebAssembly program responded with. And when I wrote this, it might have changed. Like all of those services required you to write sort of that JavaScript boilerplate stuff, right? Sort of that would accept the request and so on, except for Cloudflare workers, because they have the Wrangler npm package that abstracts all of that, right? So that allows you to write Rust without even seeing the JavaScript wrapper that would still be there, so you can run your WebAssembly in V8. And essentially, what Wrangler does is it provides some tooling and command line stuff for sort of running, compiling, deploying your Rust project as WebAssembly, so you don't have to deal with any of that, and it's actually quite a nice experience. So let's see how that works, writing something with Wrangler for Cloudflare workers. And first step is obviously implementation. How do I write that, right? So when people submit the form on the website, we intercept that submission with JavaScript, and we just do a regular fetch request, right, with a JSON body, and we post that somewhere. So that's what we need to handle with our Rust code, right? And when writing Cloudflare workers, you would also be using the worker crate, which provides some abstractions around requests and responses and so on. So our main function here reacts to fetch events, and then inside of that we use the router provided by the worker crate, right? And then we say we handle post requests to the /send path, right? So that's all pretty simple. Now the first step, of course, is we need to receive that JSON payload and pass it into some kind of struct that we can work with in the Rust program. And for that, we can use Survey, obviously, which makes it really easy. So we just define a struct here that's called payload and has a name, email, message, which essentially represent the fields in the form. And then we pass the payload that we receive, like you see there, match request JSON payload. We pass that into that struct. If it works, we go on, and if it fails, we just respond with 42 because it must have been something different than we expected, right? Next step is then actually sending the message. And for that, we use the request crate, request with a W instead of U. One note I have here is so when you're compiling to WebAssembly, you have to make sure that all of your dependencies support the WASM32 target as well. And when I wrote this, I might have missed something, but when I wrote this, the only way to check whether a dependency supports that target is to compile with the dependency. And if it says target not supported, then so if you know it's not supported, but there's nothing in like on Crater or so where you can filter for dependencies that support a particular target. Here we're using SendGrid to actually send the email. And what we do is we simply we build a new payload to send to SendGrid using Survey again with like to email from subject and so on, and then we create a client which is provided by request. We pass it like our bearer token, so SendGrid knows who we are, and that we're actually allowed to send email via the service. And then we pass that payload as the request body, and then we send. Right? If we receive a status 202 from SendGrid, that means message was sent, and we can respond with OK, like response code 200. If we receive a different code, then something went wrong. We don't really care what went wrong, so we just respond with 502. And if making the request as such failed, we just respond with 500. Right? But this is like it just works like unless SendGrid's API will be down or something. And then in our main function, so when parsing the payload that we receive in the request body succeeds, we just like call that function and send the message. Right? So that's already it. It's like rather boring actually, right? But obviously we also want to test that, right? We want to test whether it works, and we want to test whether it continues to work as we make changes, right? So let's see how testing that works. First thing, since you're compiling to WebAssembly and you're eventually running in a browser or like potentially in a different WebAssembly runtime, you can't use regular Rust testing stuff, but you have to use WASM bindgen, right? So you have to do these things. You have to tell it to run in a browser, and you have to use WASM bindgen test instead of like the regular test to sort of mark your test. But everything else is like essentially the same, except you run tests using WASM peg instead of cargo test. And that runs the tests in a browser. Then you see interactive browser tests are now available at localhost 8000, and then you can just go there and run the tests in the browser. That will essentially load the WebAssembly, run the test, and sort of like print the results into the DOM. And of course, you can also run that headless on CI, for example. Yeah, so this is one step too far. So the problem that we have with this, obviously, we don't actually want to make requests to SendGrid when we execute the test and then spam ourselves, right? Or like run into like rate limiting problems, or the tests rely on that API to be available and so on. So we want to stop that stuff in some way, right? And of course, stubbing in Rust isn't as easy as in like Ruby or JavaScript or so, where you just replace the thing with something else, or you just change like the function at runtime. But what we can do is, I'm slightly getting confused with the out of sync between the phone and the laptop. So what we can do is we can just extract the code that we don't want to run when running tests into an extra function, right? So here we just take the SendGrid stuff and inject that into its own function, request SendGrid, and then we add a new argument to the send message function that we can pass in whatever function we want to use to actually send the message via SendGrid, right? And then we call that instead of having the code that invokes SendGrid right in the send message function, right? And then we can simply inject the actual implementation in our main function, right? That we have send message payload API key, and then we pass in sort of the request SendGrid function that actually invokes SendGrid. And then when running tests, we can inject a different function, like in this case, one that just always responds with an OK result and status 2 or 2, and then we can test the send message function without actually like relying on SendGrid, obviously. And we can even, of course, have expectations, assertions in that mock function that we pass, like in this case where we sort of check that it's actually invoked with the correct arguments. Yeah, so that's testing. Last step then is deploying that, which is pretty easy because Wrangler handles it all for us. So we just run Wrangler publish and that like deploys it, right? That sort of will build things and sort of like publish it to Cloudflare Worker environment and so on. I'm not going into details because it's not like super exciting and they have documentation. You can, of course, also run that on CIs. Here last line or last 2 lines, so if we have a token on our GitHub action, and then we just run our release script, and that sort of for every successful build on the main branch, we just release it automatically. And so automation is kind of easy as well. And then finally, that's conclusion, right? And that's the question, what do we learn from this simple thing here, right? First, obviously, when talking about Rust, everyone always asks, is it fast? And the answer in this case is, sure, it's fast, right? It doesn't do much, it's Rust, it's WebAssembly, it's fast. Although, is it fast because of Rust? And the answer is not really, right? Because as you saw, essentially nothing happens in the program that we wrote, right? We just like pass a JSON, sort of transform it into a different JSON, pass it somewhere else. So the performance of this is entirely bound by the performance of SendGrid's API, essentially, right? So there's no real value using Rust here, right? It might even be a bit slower than just writing it in JavaScript, because obviously you have the overhead of sort of the context switch from JavaScript to WebAssembly and back and so on, right? So maybe there's no real point writing this in Rust at all. However, was it fun to write? Yeah, sure, right? So it was nice. It was nice writing this. And it was also relatively easy, right? It's good to see sort of that you have everything that you need. The tooling works well. You have Wrangler, you have Wasm Pack, you have Wasm Binding. It's all works well. There's no big sort of obstacles or so where you have to figure out stuff. It's all pretty solid, right? So what's the point of that? And I think the point is sort of seeing what's possible, right? And seeing how easy it is, as I said, sort of so you can, if you have a real use case where you need like an edge function that actually does something that's sort of computationally heavy, right? And then you need to be fast, you can easily use Rust for that, right? And there are many examples that are like much more exciting than this, where sort of people are doing this already, right? But for me, it was a nice experiment. It works well, it's stable. Yeah, that's all I had already. That's all we learned from that. I hope you learned something from that as well, maybe not so much. In the end, just a quick reminder again, Eurorust, but Sarah said it already, it's going to be in Brussels, October 12, 13. We have tickets still available. Early tickets are sold out, but you can still get regular tickets. If you buy the ticket as a private person, you get it really cheap. If a company buys it, it's more expensive, so it can be cheap for you if you buy privately. So that's it. Thanks.
All right. Thank you, Marco. Next up is Philip with Cloud Computing with Rust. And leave the microphone, please. The microphone.
Oh.
Okay, so in the meantime, when is your reference date? Now you should know.
October.
Yeah? Good.
One second, please. Do we have a picture? Nice. Okay. So, yeah, thanks for having me here. I'm Philip Renot from Console. I'm a software engineer there, and today I'm going to talk a bit about cloud computing with Rust, or in other words, better resource utilization of whatever you want to run in the cloud. So at first, I think you all know it. Like, we have several web technologies which have like good performance, bad performance, good memory usage, bad memory usage, and so on. And I would put Node.js, Ruby, PHP, Python over there. So of course there's some Python which is quite fast for deep learning and so on, but this is actually mostly not Python really. But I would say that it's somewhere here, and I would put like Java and Go here. So I think Java has really bad memory utilization as far as I saw it, and Go does it better, and they have similar performance depending on what you want to do. And where is Rust? Right? Yeah. Hopefully, actually, or we did it wrong. So whatever you do with Rust, it seems like either you do it really wrong, or it's very small, very performant, and has very good memory utilization. So this is, I think, not a lie here, but I think there is some kind of a different mindset about Rust. So when I ask some colleagues or somebody about what about using Rust, and they say like, why should I use Rust if I don't need performance? This is mostly an argument for them, but of course, if you need to have like a lot of performance for your application, then Rust is really a good match for it. Like, we know it that C or C++, of course, it's also very good and performant, but what about having a solid and robust piece of software you want to write? Then Rust is really a bit better for this. But what about the left side? unimportant performance applications, does it make sense to use Rust here? And yeah, this is a bit of a discussion every time. And what I want to say or to show is that indeed it really makes sense to use Rust for also not very performant applications, because let's see why. Like a server, I mean, what does it mean to be a server? As a piece of software, it's like waiting for others, because you get something, you have to process it, and you have to wait for something like downstream I/O, which can be a database or another microservice or whatever. So it seems like deserialization data is always a thing. Then you have your downstream I/O, and then you have like serialized data and send it back, something like this. And if you use Rust, it doesn't get very fast actually, because we also have to use our downstream I/O, and we can maybe just spend like a few microseconds here or less because it's Rust, but all in all, it really takes also 40 milliseconds or more because of the downstream APIs, downstream I/O, sorry. So this is not quite convincing for using Rust really. So let's go a bit further. Like, if you're a server, what does it mean also? Like, it means you have to park requests. And this is where it comes a bit, it's a bit more interesting, because what other languages mostly have, or technologies, is they need a lot of memory. So what we have here is like, if you have a few clients that come in at the same time, you have to kind of store everything in your memory, and it piles up to a few megabytes. And when we use like Rust, it's not the case, right? So mostly it's a few kilobytes per client or whatever you have as data, but it's not a big deal. It's not that much memory that you have to use. And again, it seems like you're a bit faster. I mean, those arguments are still not very convincing, but if we have a look at a bigger picture of everything, then we have like, we have something like, I would like to call virtual costs. Like, how much do you have to pay to have all the resources in your cloud to be able to respond to everybody in quite good real time and so on. And I think that's a thing where Rust really matters actually, because this example is like a microservice architecture which uses like microservice 1, microservice 2, then something returns microservice 3 and so on, and it somehow piles up. So each microservice needs to have memory and everything piles up, and you have to pay for this. You need to have instances with a lot of memory, and this is what you have to pay for in the cloud. If you use Rust, you could reduce those costs. Like, this is just an example. It's not really science, but it's an example which is valid for a lot of applications, where we see that if you measure the memory, you will have like almost 10% of memory to use for Rust. And you're a bit faster. So you can kind of think of, you have to pay the area here. And as you can see, like, maybe it just costs like 10 or 9% at all if you're using Rust in your cloud. So of course, other technologies have a few solutions for this, because everybody knows that not all technologies perform that good in the cloud. So what we're doing is like cloud providers having saving plans. Like, if you have one instance 1 year or 3 years or whatever, you pay less. It's about 60% where you can reduce your costs if you're just taking instances for 1 year or 3 years. So that's a big deal, actually. Most of the companies also decide to go serverless, which is another buzzword for, of course, there is a server, you have to pay it, but it's a bit more that the application you write will not implement the server, but maybe one route or 1 or 2 routes, events, and so on. So this is what serverless means. And yeah, another deal is like you can scale to 0, which means like if there are no requests, you will scale to nothing. And if there is a request, your system will start. And you can also have like a small amount of instances. And if you have higher loads, you can use auto-scaling for this on demand. But as I said, auto-scaling means on-demand instances, so maybe they cost a bit more. So it's not serving plans here. And another thing is you can use like ARM instances. They are a bit cheaper in the cloud. So those are great arguments, but you can also do that in Rust. So those are not arguments that only a few technologies can use, but actually every technology can use. But there is more, like the cloud has so-called, or mostly so-called computation optimized instances, where you have a different ratio between CPU and memory. So that means you can have instances that take a bit less memory and the same amount of CPUs. And of course, they are cheaper because they have less memory. So that's one thing that makes sense for us, actually. My reason number one, it's not the important reason, but the reason number one for using Rust in cloud computation is actually to save operational costs, because you can start somewhere like immediately will save cost if you use better saving plans or whatever and reduce your instances you need. But of course, operational cost is just, most companies, their operational costs are less than like what you have to do with development costs. So maybe it's not the most important aspect here. So that's the second point I want to describe here. So in relation, writing software is very expensive. That's the thing that's not specific to Rust or whatever. That's also the case. So optimizing operational costs makes sense. It's good, okay. But maybe it makes more sense to really optimize development. So I did a short research, and I checked like, what do I get for one virtual CPU, 1 GB of memory, and 1 year instance in average for public cloud providers? How much do I get for development? What do you think? Like 1 minute, 1 hour, 1 day, 1 week, or 1 month? What do you think? Just a gut feeling. Which magnitude do we have?
So what are we comparing? An hour?
1 hour? Other ideas?
2 hours.
No, it's 1. It's magnitude. 1, 2 hours. No. So also 1 hour?
2 hours.
1 month.
1 month?
1 day.
1 day? Okay. 1 hour? So of course, I know that Rust developers are maybe a bit more expensive, maybe. But in this case, it's about more than $100 you have to pay for an instance here. And like maybe in Munich, you have to pay more than $100 per hour per developer, but it's the same magnitude. So you don't get a day development for this. So I think that's really interesting. What we do in the company is we have like a lot of project business stuff. And I was thinking like, how can we use Rust for our customers? We do consulting stuff. And I think that one of the reasons is that mandatory code quality gates, they are there. You cannot, of course, you can ignore them. You can write unsafe Rust and so on, but at least it's some kind of part of the language. So you have it per default. Then you have like explicitness. So what we have is we're getting code from the customer from another company that they maintained it for years. And then you have to find out what they wanted to say with their code. And that's actually a thing where I really love Rust, because it's kind of explicit. So you cannot like lie in the code. You cannot throw exceptions and so on. You have to really be explicit at this point. And also for a team reviewing code and so on, you don't have to check everything like what is throwing, what is returning, and so on. You really have explicit code here, and that's really important for me actually. And yeah, the third thing is we have like a common sense, like most technologies allow to have discussions like, do we go left or right? And in Rust, it's mostly like, we will return results, we will make it async or not, and we will use enums and so on. There are mostly no discussions about, for example, return values or telling the caller like, what do you return here? Will you throw? Will you return a false value? All of those crap discussions you don't have in Rust. And that brings me to like additional advantages for project business. I mean, a few people disagree with this, that onboarding is really easier with Rust, but I would say that it is, because of course there is a steep learning curve and so on, blah, blah, blah. Everyone says it, but as soon as you're getting to use with Rust and write a bit of code, it's really nice to use. And there is actually, yeah, onboarding is really sort of a healthy process you have when you start a project. You need less documentation about technical stuff. So if you use Cargo, I don't know what others use, but if you use Cargo, then I will not say that Cargo build will build the project, because who wants to read this? And yeah, there are many defaults. And another thing is that big business customers have like project blueprints, because they want that all of their customers, or all of their customers which creates a service should use the same technologies and so on. And if you have a setup of Cargo and those stuff, you really have to use a more lightweight blueprint for this. It's not like you're not allowed to use this and this and this tooling, but it's quite of a default, like which almost all projects use in web technologies actually. So yeah, another thing, I mean, I did not pick slides. We all know like Rust has ownership and so on. Everything is okay, but this one is more about the cloud computing stuff. And the really good thing about Rust is really the meta-programming part of it also, because this code generation feature is actually something which opens all the doors you may need in the cloud also. So for example, about API contracts, like two servers have to communicate with each other, and we can use like normal Rust macros to do compile time validations for this. And this is really, really, really cool. Like also a bit more compile time checks like configuration. You don't want the server to crash when it starts because someone changed a YAML file, or I don't know, did a typo and it's not valid YAML anymore. I mean, we don't want to have this in runtime. And also like offline integration with SQL, for example. So it's possible that you write a piece of code which doesn't compile if it's not correct SQL in your Rust code. And it checks this against a real database you're running. And I don't know which language also have this, and I really like this. Another thing is like resource embedding. Whatever you want to have, you can just throw it into a binary, and you don't have to have like one binary and one configuration file, or one binary and two pictures. Just one binary. It gets a bit bigger, but it's okay. So we can have resource embedding here. And also nice is like programming paradigms like higher order functions or decoration. For example, you want to have like tracing in a function. You don't want to write boilerplate code to implement tracing. You just throw a macro for this, and you have a higher order function that does tracing for you. You have like cross-cutting concerns like logging and so on, or tracing also. You can have intercepting, and much more. So I really like this from Rust, and other technologies don't have this actually. So reason 2 for me is like safe development and maintenance time with Rust. I think it's also really important. A lot of people disagree that it's getting easier with Rust, but I think it is getting easier because there is much more or less questions about how should we write code. So I would like to come to a conclusion, like in general about Rust. This is not about the cloud computing part here. We have like a modern general purpose technology with lots of synergy and effect potential. Like the more you write Rust code, the higher you have a community or co-workers in your company, and you can ask them. And yeah, although if they're using like completely different technologies or not technologies, different projects, maybe not web technologies, but if you use Rust, you can ask like anybody in your company about Rust for this. We have like a very fast growing community. So this is really, yeah, there are many statistics about this, which prove this. And I know again about resource utilization. It's not just about like you want to have high performance services and you want to use all your CPUs or memory, but it's also about using your developers correctly with Rust. So don't waste time with silly questions, use Rust. Yeah, about the cloud computing part here, I think that for the short term, operational costs will be reduced. I mean, I don't have to prove this, I think. For development costs, I think it's not short term, but it's like mid or long term. So of course, it's not for free to onboard your developers using Rust, but it's possible. So try it. And yeah, the longer you wait, the more tools and software you find rewritten in Rust or whatever. So this adoption of using Rust in the cloud has already started. So I think it's time to onboard actually for this. And that pretty much is it. If you have like questions, please reach out. How many minutes do we have? 2 questions.
Are there any questions?
Startup time.
Startup time?
Yeah, in serverless, how about, is it different in Rust or?
Yes. So in Rust, you have like 2, 3, 4, depends, milliseconds. Other technologies are much more longer, but they try to use like a smart technology to accelerate it, like starting lambdas and freezing them and use the frozen, images to improve startup time. I don't know, that's so much magic. It's a bit easier to use Rust and have a good startup time. Yeah. Yep.
To what platform did you compare the memory usage, and why do you think it's so much more efficient with respect to memory than, for example, Java or .NET?
Which platform?
Yeah, I mean, like, did you compare it to Node.js or to Java?
Yes. Yeah, so typical Java machines or JVMs, depends on, again, about the software, but if you use like enterprise Spring Stack, you will start at like 2 to 4 gigabytes minimum.
Okay.
Actually more 4 to 8 gigabytes, depends on what you're using. And Rust, you can have like, it really depends what you want to do, but you can use like a few hundred megabytes of container memory.
So the biggest issue is actually the framework, like Spring. I mean, because when I think about Java, you have everything should be like garbage collected, and you just have pointers to one object. So you don't even need to clone something like we do in Rust when, the power checker doesn't let us do what we want to do, we clone it.
Yeah.
And in Java, you never have to do that because you can just add a reference and everything is done automatically. So I would have thought that actually in Java, you can be pretty efficient with your memory.
Yes, but no, you can't. No, you have a lot of overhead. So I don't know in detail what you need, but if you just measure, like, I mean, there is like Spring and Spring Native. Spring Native uses a bit less memory, but it really it doesn't compete with Rust at this point. So like the factor 10 I have in my slide is a measurement. It's not a idea from me, but yeah.
Yeah, I was just asking if you have any idea where this is coming from. like technically.
Yeah, I mean, what you have is, because if you use a garbage collector, you can store everything somewhere and have reference pointers. And no one cares about removing references. And maybe you're like having objects referencing to somewhere where you don't need it. Like there we are in this dependency injection stuff. And it's like Rust is really, it starts somewhere, it ends, and then you have the same memory after it, mostly. No leaking at all. And other measurements are like memory is maybe a bit raising with time and so on. Yeah, so this is, yeah.
Another major issue is that you don't necessarily know when the garbage collector is going to context switch and then run the garbage collection. So if you have something that's latency critical or non-critical, it could pop up anywhere, and so you have these big gaps in time.
Another thing is that you will probably start your Java application with more memory to have it then, because it seems to be a bit faster to have it allocated before. And if you write a Rust code which like pushes each and every item, and you have like 100,000 items, maybe Rust, I don't know, is slower, but you know, like you should not do that. You will stick to like, I know how many items I need, so I will allocate enough memory for this. Yeah. So these are optimizations, and also garbage collector is correct. Like if the server needs to like process the requests, maybe the garbage collector says, okay, I will wait until it's getting critical, and then I will remove like the zero reference counters. Yeah. But it's magic. This is the problem. It's not predictable what your application does. Yeah.
And the other factor is also that in Java, the JVM, one is working basically the entire time with references. So like in Rust, if you have a structure contained in another structure, it's just contained in that structure. It's just part of the structure. In Java, you have a structure where you have a class which refers to another class. Then you actually pay for the storage of the objects and a reference in one class. So it's and that adds up. Like you have if you have an array of objects in Java, you actually have an array of references. You can't just store the individual objects directly in the array. It's like you store a reference, you store actually an array of references and then all the individual objects separately. So that really adds up.
Yeah.
Also, I guess because in languages like Java, you have runtime reflection, right? And it's a lot of metadata, so in memory at runtime, so that you don't have languages like Rust or C over.
Yeah. Also,
Every object also has overhead it isn't that.
Yeah. Okay. Cool.
All right. Thank you, Philip. I think some of you might be thirsty, or the other end of that. So feel free to grab another beverage. We're gonna do a 10-minute break, and then we're gonna continue with another talk with Bradford bringing Google tests to Rust in 10-ish. That's quite okay. with part 2.
Ready? Okay. So, welcome to the third talk of the evening. I'm Brad Hovenen, and I will be talking to you about a new test assertion library, which we are bringing to Rust, which is based on the famous C++ library Google test. All right. So first, a couple words about me. I'm on a Mastodon instance, in case anyone's interested. I've been working at Google as a software engineer on and off for a total of about 6 years. Independently of that, I have about 4 years of experience with Rust, although mostly outside of work. For about the last year, I've been working on Rust tooling at Google as part of a so-called 20% project, which just means I'd spend about 1 day a week outside of my main assignment helping the team out doing Rust tooling. Okay. I'm going to start today with a few motivating examples. So, just using out-of-the-box material, if one wants to write tests in Rust, how does one typically do it? Well, I think every canonical documentation example I've seen uses the assert EQ macro. So you say assert EQ something equals something else. That might be fine for what one wants to do for really simple examples, but as soon as you want to do something like, I just want to assert that this container, this vec, for example, contains a value, then assert EQ doesn't necessarily do it for you. Now you can use something else like assert bang. You can go really fancy and like add some logic and say, well, if this condition is true, then just panic. Just say test failed. Now, what do we want to be able to assert? I'm just going to give a kind of fictitious example here that, which kind of reflects some of the kinds of things which I've run into in projects I've done. So let's just say you have some data model which involves a country which has some set of cities, and each city has some buildings, and the buildings can be of different types. And one of those types is called the Capitol, and the Capitol, you can see a picture here, is the Capitol in Washington, D.C. That's the building which contains the legislature typically. And we want to assert that every country has some city which has a capital, typically the capital city. Okay, well, how will we write the assertion? Well, I guess one option is I could just iterate over the cities of the country, and then in each city I could iterate over the buildings, and then in each building I could check, and if the building matches, then I say, yep, it's fine, I return. And if everything fails, then I panic at the end. Now, this is a lot of logic. It's a lot of for loops, a lot of, I get a headache when I read this. Like I want my tests to be really simple and straightforward. And when I look at this, it's not simple or straightforward. It's not, like I really have to interpret what's going on. Now, many people in the Rust world also like functional idioms. So if you like functional idioms, you could also do the same thing by, iterating the iter method and, calling any and doing so. I don't think this makes the code any easier to read, frankly. I think this is maybe even a little bit less straightforward. So I'm not happy with that either. And what's more, just regardless of how I do it, when the test fails, what do I get? Well, I get this message which says the thread panicked with a message no capital found. And okay, that's fine, but why? Was it because there were no cities present at all? Was it because there were no buildings present in any of the cities? Was it because just none of the buildings happened to be a capital? I don't get any context from the failure message. So imagine like I'm sitting here, I'm not the one who wrote this code. I'm now coming back 2 years later. The developer wrote this code, left for another team a long time ago, won't talk to me. And now the test starts failing. And all I get is that message.
pretty frustrating experience. Now, as a test developer, I could be really nice and friendly to my future colleague or person who comes after me, and I could add some information to that panic message, because I know as a responsible developer, I will do so. I will make life easier. Well, the thing is, I don't want to have to do that. I want to focus on the code I'm writing. I don't want to have to focus on how to make the test failure message perfect. That just distracts me too much from the actual task I'm trying to accomplish. Okay, so what about some of the more, let's say, advanced macros like assert bang? Well, I could write an assert bang. Let's say assert that this something contains something else. And if that fails, then it will give me this message: assertion failed. This contains that. Okay, I know that something didn't contain something, but what were the values of this and that? I still don't get much context. There's the assert EQ macro, but that's pretty limited. I can only check equality with that. Now, there are other solutions out there. There are great. There's one called Handcrest 2, which is a port of the famous Handcrest library for Java. And there's another crate called Galvanic Assert. And these have pretty similar setups. And these use so-called matchers. So I can say assert this, and then I can just write some expression using these so-called matchers to say what it is I want to assert about the actual value. This offers some help, but for what we're trying to do in my project at work, this doesn't quite suffice for reasons which will become clearer later in the talk. And the projects which we found seem to be a bit stagnant. They haven't been updated in years. So that's kind of the motivation. So what is Google Test Rust? So let me start with the antecedent, Google Test. So this is available on GitHub. It's a C++ testing library. It was developed at Google by around the year 2008. It was, I'm not sure whether it was the first. I think it might not have been the first C++ testing framework, but it was among the first. And it's still pretty widely used as far as I can tell in the C++ community. It includes a lot because C++ doesn't help you much. It's not like Rust, which comes with, testing out of the box. So this includes things like a test runner, assertions, a collection of matchers similar to what we just discussed with Handcrest and Galvanic Assert, and a mocking framework. If you don't know what a mocking framework is, it doesn't play a big role in this talk, so we'll skip over that. So as I mentioned, it has widespread adoption. And it's quite mature and powerful if one accepts the limitations which C++ places on doing these things generally. So I've seen Google tests. I find them to be a little bit, one needs to get used to the syntax a little bit, but okay, it does its job. In particular, its matcher collection is really quite powerful. So we want to write better test assertions than what's available out of the box with Rust. Existing crates don't quite satisfy our needs. And so we've decided to kind of take Google Test and bring it to Rust. What are the goals here? Well, first, we want to bring more powerful test assertions to Rust, clearly. But also, at Google, we have a lot of C++ developers who use Google Test in their day-to-day work, we want Rust to be an attractive environment for them. And that means we want to be able to provide a library which, for testing at least, which offers kind of a similar functionality with which they're already familiar with Google Test. And there is probably likely going to be the need from time to time to take existing Rust or existing C++ tests and port them to Rust. And we'd like to make that easy. So it should not, without locking ourselves into Google Test idioms, because there's a lot of historical baggage there. We would like there not to be much cognitive load involved in taking a test written in Google Test in C++ and just knowing how to do the same things in Rust. Now, there are some things we do not want to do with this. We're not interested in replacing the Rust test harness as part of this effort, so we're using the standard Rust test harness. We are not supporting parameterized tests or mocking in this library, basically because for those, there do exist libraries which actually satisfy our needs, and we're happy to use the existing libraries. All right. So what do we offer with Google Test Rust? Well, first we have some new test assertion macros. We have a framework for writing matchers, similar to the ideas of Google Test and Hamcrest and so on. And we have a rich collection of matchers. All right. So that said, I'd like to talk now a little bit about what we can actually do with Google Test. And I'm going to start with the matchers which we offer, because that's kind of the most central part of it. Okay, so first, some of the basics. As you can see, we have a macro also called assert that's following the same pattern as Hamcrest, Galvanic assert, and so on. We offer all your standard things, EQ for equality, greater than, less than, greater than or equal to is GE, less than or equal to is LE. And one can use all the basic logical operations to combine them. So you can assert that, for example, a value is greater than 1, dot and less than 3. You can also say a value is not greater than or equal to 3. That's all possible. How does this appear when a test fails? Here we actually try to make it look familiar to Google Test users. So the error message, I mean, for anyone who is familiar with Google Test, the message which you see here is actually really similar to what one sees in a test failure with Google Test. So it will say the value of the stringified value expected to be a description of the matcher you used, the actual evaluated value it was, and then some kind of explanation, which isn't equal to 3 in this case. And then it tells you where it happened. That's kind of the main part. I have, there's a little bit of extra stuff which appears because we're using assert that, and assert that causes the thread to panic. And so just like every other test assertion library. So there's a bunch of other stuff which Rust itself will print out, but the interesting stuff is here in boldface. Okay. We also allow matching on floating point values. So you can say, well, I want to assert that this value is near a particular value or is approximately equal to a particular value. Of course, when you assert on floating point, you never say two floating point values are exactly equal to each other, because if you've done any non-trivial computation, they practically never are exactly equal. Instead, you always say they're approximately equal, and this approximately equal will kind of pick a reasonable tolerance and say, yeah, good enough. You can also check for not a number. You can check, I mean, of course, you can ask for string equality. And by the way, this works just fine if like one of these is an owned string and the other one is a string reference. That's perfectly fine. It's not, you don't see it in this example, but you can do it. And you can also do other things, like you can call extra methods on the equality matcher to say things like, well, yeah, I want to assert that these strings are equal, but I don't care about ASCII case. So just ignore that. Or maybe because of formatting things nicely in the test, the value which I'm using in the matcher might have some extra white space somewhere. So I might say, yeah, ignoring the extra white space which might be there, it's fine. I only care about what's not extra white space. Oops, sorry. There. We also support, of course, string containment, and you can call these same configuration option methods for the various string containment matchers. So contains substring, starts with, we also have ends with. We support regular expressions. So you can say it matches a regular expression or contains a regular expression. We support matching on option and result. And here we can see an example of what we call composing matchers, which is really where the power of matchers starts to become evident. You can say this value is a sum, so it's an option, and it's a sum variant whose value satisfies this matcher which I'm passing in. So sum whose value is equal to, this is a string. And result, you can say, or you can also match on OK and error variants. We have a pretty extensive set of matchers for containers. So you can match on the size of a container. You can say, I want to assert that this value contains something which satisfies an arbitrary matcher. And I can say, I want it to contain, this number of elements satisfying this matcher. I can also say I want all the elements to satisfy this matcher. I can also assert that a container is just empty. And then I can do some even more kind of advanced things. I can say, okay, I want to assert that all the elements of this satisfy the following matchers in this order. Or I can say all the elements of this satisfy these matchers in any order. So they're kind of in a one-to-one correspondence with these matchers. And that latter approach also is really nice for unordered collections like hash sets. Because with hash sets, of course, you can't depend on they're producing any particular order when you iterate over them. So then you don't want to use any kind of matcher which enforces a particular order. So you can just say, yeah, I just want this to contain these elements, basically, which satisfy these matchers. I can also do kind of superset subset relations. So I can say this container contains each of the following things which satisfy these matchers. Or it is a subset of some larger things corresponding to these matchers. There is a notion of pointwise matching. The way I think of it is like, suppose you have some set of measurements and you want, and let's say you have another container, another like vec, which says, it should be, or the individual values should each be larger than the original values of the first container, or even maybe that the two containers should have values which are correspondingly approximately equal to each other. I can use this pointwise matcher for that. I can just say, okay, assert that all or the elements in this first container are each greater than the elements in this other container, or each approximately equal to the elements in this other container. And here we get to a feature which is, let's just say, I mean, I'm not aware of another testing library which offers something quite similar to this. It's something I've sorely missed when I worked in the Java world in the past. And this is the notion of pattern matching. So here what I can do is I can say, I have a struct and the struct has some fields. I want to assert that my value, which is a value of this struct, has fields which just match these matchers. And I can do that recursively. I can say, okay, I have my outer struct, and then this struct contains an inner struct, and then I want to assert that, the inner struct also matches a pattern where the fields match these matchers. And I also we also have a shorter alias for that in case it becomes too much to type. You just say pat bang. This also works for enums and structs. So I can say like, I want to assert that this value is this particular variant of an enum containing these particular values. And this pattern matching also works with method calls. So I might have a method like getFoo on my original struct. Then I can say, okay, I want to assert that this value, if I call getFoo on it, that I get a value back which satisfies this matcher. This is particularly nice if I don't control the struct. Like I don't have access to the fields in the struct, but I may have access to a method which would get me the information on which I want to be able to assert. And I can also pass additional parameters to that. That also works. Finally, Rust also has a notion of tuples. Unfortunately, matches pattern doesn't quite work with tuples for reasons, but we have another matcher called tuple, which matches on tuples, but only up to, I think it's 12. It's only up to the length of a tuple, which is supported by or auto-derived by the debug trait. After that, it's not supported, but that's enough for, I think, most purposes. So the nice thing here is, because of this composability and all this pattern matching and whatnot, you can actually, combine these things in kind of arbitrary ways and really you can assert on really complex data structures pretty easily. So you can say like, I have a vec of structs, so I want to assert that this vec of structs actually contains something where if I call a method on it, I get a particular value. And I can do that without having to kind of, write all this extraction logic and figure out, get at the value which actually satisfies the criteria. What's more, it will then build what is hopefully a reasonable failure message containing a lot of contextual information. So in particular, tells you exactly what was expected, including all the matchers contained in each other. Tells you what the actual value was. And it tells you something about why the actual value was not matched. And depending on the matcher you're using, it can actually tell you a lot about why the value was not matched. And what's more, the value, the description of the expected value, as I say, it's built from all the matchers you have. So you can see that it puts this thing together by actually going through all the matchers and kind of letting each matcher contribute some information. And by the way, that would also be true. This example doesn't quite work for it, but this would also be true for the explanation as to why the value did not match in when the example is relevant for that. It's easy to write your own matchers. I just have to implement a trait. There are two mandatory methods. One which just tells you whether the thing matched or not, and the other one which basically produces that string description which you saw in the failure message. There's a third method called explain match, which you don't have to implement, but is useful, especially when the matcher contains an inner matcher, because then it can give more contextual information when a test assertion failure match a failure occurs. The output of the explain match would then appear in that third section, which is explaining why the matcher did not match. All right. So I want to say a few words now about some of the design choices with this library, which are a little bit unusual for test libraries in Rust. So we prefer to communicate assertion results through result. Most Rust test libraries just panic on assertion failure. Like that's the standard way of communicating the test failed, just panic. So we prefer to use results. Why is this? Well, the first problem is kind of technical. At Google, we have some pretty large binaries, and some of these binaries run some pretty extensive initialization before calling main. The result of which is that they have really long startup time. And you combine these two facts together, panicking is really expensive. Therefore, we try to avoid it as much as possible. The second reason is more about the library itself. We want to support so-called non-fatal assertions. We'll describe in a few minutes. So thus far I've used this macro assert that. Assert that is actually based on another macro which we have called verify that. Verify that is a macro, takes the same arguments as assert that, but it just evaluates to a result whose error variant indicates failure. One can use then the question mark operator. If the test returns result, the Rust test harness supports this. The test can just return a result, and an error variant will be treated as failure. So one can use the question mark operator to just return that result and say, yeah, this failed. Assert that then is nothing but verify that and unwrap. You just call unwrap and it will panic. Using verify that does have a small advantage over assert that, namely that the failure message is cleaner. So this is the whole failure message if you use verify that. You don't have this extra boilerplate which kind of obscures things. Okay, non-fatal assertions. Let's say you have a test which has two noted closely related assertions. So not two wildly different assertions, but two assertions which belong in the same tests, let's say. Well, the problem is if the first assertion fails, the second assertion doesn't execute. And that might make things harder when you want to diagnose problems. So you might miss important information about the test failure. For example, maybe it's actually the second assertion failed, or the second assertion would have also failed. And maybe that failure message would have told you why it's really failing and what really went wrong. And the first one just says, screwed up, I can't help you. To help with this, we offer a thing called non-fatal assertion. This is also a feature which comes from Google Test for C++. When a non-fatal assertion fails, the test is marked as failed, and it is reported as failed, but it continues to run. And the macro for that is expect that. So just replace assert that with expect that, and you get a non-fatal assertion. But the other thing is that you have to use Google Test : test as your attribute on the test because it needs to add a little bit of boilerplate to make that work, and the test has to return a result for reasons. And this is, by the way, the other reason why we prefer not to panic, because if we just panicked on assertion failure, then there was no way we could do this thing with non-fatal assertions. All right. So in summary, Google Test Rust is a new test assertion library for Rust based on Google Test for C++, which offers test assertion macros, a way to write matchers to assert arbitrary values of a value, or arbitrary aspects of a value, and a rich set of matchers. And I have some references here. Google Test Rust is on GitHub. We released it for first time back in December, so it's relatively new. It's on crates.io. I just pushed 0.5.0 earlier this week. And I added also some links to the other things I mentioned here. Thank you.
Thank you very much, Bradford. Are there any questions?
Yes. So thank you for the talk. In my experience, and having seen a lot of Google test code and a lot of Rust test code too, I find it that reading Google test code usually, probably to some degree because it's C++, but not entirely, I would say, was just more complicated, right? And I think this goes into what all this is about. You say that like Google test is mature, sure, but like saying CMake is mature is also true. But I wouldn't say CMake is a nice like thing you should redo if you have a time machine. And what essentially you created is a DSL. You created a small little language, and it's not trivial, right? Like you showed some pretty complex matches. And if you go back to the very first example you showed, if I had to have a test that fails that I didn't write, and then I have to go back, and it's some complex DSL matcher in there versus 2 for loops, I know what I would prefer to change, right? Like the one thing is Rust. I know Rust, I can change Rust, but like the other thing is complex. It's hidden inside macros. This proc macros, I guess, right?
The only proc macro is this Google test : test thing, which I showed at the end. The rest is all declarative macros.
Okay, so that's of course nice plus, but anyway, still it's macros, right? Like it's harder to understand, harder to debug than just plain Rust code. So I worry that all this freedom will give people like the desire to build more complex microcontrollers instead of just doing Rust code to pre-process your data and then do a simple SR on that.
Yeah, I mean the library. There's no tool in the world which can't be abused. So so yeah, sure. I mean, one can use the library in a way which would create really really hard to understand, hard to maintain test code. I would say it's a matter of using good judgment. And yeah, I mean, just because it is possible to do these things, you're right, it doesn't mean it's always a good idea. I mean, it may actually be a good idea, like a better idea in depending on the context, to do that pre-processing and extract the data which you want to assert. But I think it really depends on the circumstances. I mean, there are times when having that extra context is super helpful in understanding a test quickly, or understanding why a test failed really quickly. So I'd say it's there's no single answer to that, or no single answer. I mean, there's no one size fits all solution. I think it all depends on context. But that said, I mean, this library provides some facilities which do allow for cases where one needs to one wants to provide that additional context, and one needs to look inside a more complex data structure. So, yeah.
I think it makes a lot of sense if you have a container ship full of C++ developers that need to learn Rust. Like this makes the transition really, really easy.
That's also true, and that's one of the big motivators behind the design, is to make it easy to port.
The big, clever, complex abstractions in Rust. But like, now, just one last small little suggestion. You had one measure that's called size.
Mm-hmm.
I immediately thought of size of, so like the type size layout thingy in Rust, because usually it uses len for anything that's about the length of the stuff.
Oh yeah.
So maybe if you want to make it more idiomatic, I would use the word len instead of size.
Okay, yeah, good point. I think for that we probably just took the name from Google Test and just
vector size
copied it. Yep.
Yeah, I have one question. It's just a small one. The expect that macro that you showed, which accumulates even failures over the whole test run, how would it then present them to be still understandable?
It just
Is it bullet points?
writes one failure after another. So it just, when you see the test output, you would just see, it would just print like, failure. Like, I mean, this 3-line thing.
And the end with the line number as well, right?
Yeah, exactly. And always with the point where it occurred.
I find it very helpful. Like the idea.
Yeah, I think so. Actually, I'm a physicist, and I really started programming with Rust. So before that, I just did some Python, and I never really did much C++. And for me, this way of writing code in Rust using closures, so lambda functions, has become really natural. And I think, so in the beginning, you showed this example that using this iterator and then any syntax for making sure that something is contained in a collection. You said it doesn't really help. I think it's the right way to do it because I've learned that from the beginning, and I think it really expresses what you want to say. And I would really like it if your library could use this closure syntax and then somehow transform it using a macro or something and use the syntax to generate these error messages you have been talking about in the assertion phase.
Of course, this is always a matter of perspective and, to what one is used.
Yes.
I mean, if you spend a lot of time working with lambdas and closures, then you will find that more natural. Other people who work mostly with for loops and so on would find it different. But there are various matchers which do take closures as arguments. So, for example, we have a predicate matcher where you can just pass an arbitrary closure and it stringifies that and that closure which you pass in and says like this, this predicate failed with these values. So that's available. There's also a property matcher, which is kind of similar. You can supply. Oh no, sorry, it was not property. Pointwise was an example where we can also just supply a closure as an argument. So there are various places where one can use closures, but sometimes one does use it, sometimes one doesn't. It depends on the matcher.
But I mean, my understanding was you wanted to have something that's familiar to people who have used Google Test a lot, right?
Yeah.
So I think from that point of view.
Yeah, sure.
The example you showed in the beginning, do you have it in the Google Test? Like, could you show us that, or is that something?
Oh,
because that would be interesting just to see the comparison, right?
Let's see.
Maybe I missed it.
Sorry, I didn't actually convert that into Google Test, but that's a good point. Maybe I would say, I think I showed all the matchers one needs. Let me go back. Okay. Yeah, this one.
I was just curious.
Yeah, I think I showed all the matchers one would need to use to make this work. So I'd say maybe exercise to the reader. But yeah, this with a combination of contains and matches pattern, one can do this.
Okay. And the second question I have is at some point there was a not operator, right?
Mm-hmm.
And I'm not super familiar with Rust, but you use the matcher inside of it and you didn't chain it, and it's some other matcher you kind of chained it. So my question is there like a technical reason for that, or is that like a syntax thing I'm not super familiar with?
So let me go there. Yeah.
So you use the or and as like a chain thing, and then a not.
Yeah, I think the reason for this is to make it read more like a sentence. So when you say like assert this value is not greater than or equal to 3, you would read it that way. You wouldn't say assert this value is greater than or equal to 3 not. you wouldn't say it that way around. So I think it's really just about ordering it so that if you read it, it would read like a sentence.
Okay, that makes sense.
So I was wondering, what is the hardest challenge you found when developing these? Because I imagine, like, for example, for the not greater equal or something like that, to maybe juggle with types or maybe like the compile times or anything in particular.
So the question was, what was the?
What is the hardest challenge that you faced? Like,
what was the hardest challenge? I would say, in general, and maybe I'm biased towards recency here, but I would say probably dealing with like making the matchers sufficiently generic that they work in like all the different cases with all different kinds of types one might want to use. So, for example, Rust is a little bit like you start to run into the bounds of like the decisions in the Rust standard library about what traits exist and what things implement what traits. One thing which we encountered was there was no uniform and reliable way to get the size of a container. So for a while, we were just saying, we just created a trait and then implemented it for every container we could find. Just say, give us the size of this container. We've dropped that and switched to a different solution now. But it's these kinds of things where it's like, okay, I got this working now on Vec, and but it doesn't work on HatchSet because that doesn't quite implement this trait. And okay, I also want this to work on a slice, and but now there's nothing which implements all the traits, and it's And what's more, in Rust, there's no notion of specialization. So if you implement something for a trait, like if you do a blanket implementation, let's say you implement a trait for some for anything which implements another trait, then you can often do that, but you can't then implement that same trait for a concrete type, because theoretically, even if the concrete type doesn't implement the trait, if the concrete type would implement that trait, then the Rust compiler would say, I don't know which implementation to use. And it doesn't have any rules which say I prefer this implementation to that. If it sees there are two possible implementations it could use, then it just bails and says, I don't know what to do. Which is kind of understandable. But it's even worse than that. If you do a blanket implementation for anything which implements, let's say, the trait foo, and then you have a concrete type bar and say, okay, I also want to implement my thing for bar. Then the Rust compiler will complain saying, but you might implement foo for bar later. And so I won't let you do that. And you run into all these little constraints, and it becomes really, really hard to find, just to thread the needle just right so that you can actually cover all the different types that you want to support.
Are you looking for like any nightly feature or something like that?
There is actually an RFC out for specialization, and I will be just celebrating when and if that comes into the language.
Yeah, you've shown the matches pattern macro, and because Rust already has pattern matching, it seems like you can interoperate between the Rust pattern matching and the Google test matchers. So why not make that the default then? Why do I have to spell out matches pattern? So for example, with the sum function, it struck me a little bit that this lowercase sum is the Google test matcher, and then you have the capital sum is just the enum variant.
Yeah, so I mean, of course, you can use matches pattern and with sum. I mean, that is just another way of doing the same thing. It's just that lowercase sum is shorter. But if the question is like, why do we need to have this matches pattern macro? This kind of goes back to long discussions we had trying to design this thing. We really went over for a long time, like how could we make this work within like just using Rust pattern matching, and we couldn't find anything which actually worked in a reasonable way, especially if you consider that you don't necessarily have control over the type. So, like we were experimenting with things like, you know, let's try a macro which creates a matcher for a given type, but then you can only do that if you control that type, and so it's pretty limited in what you can do with it. So it's basically, after a lot of cycles, we ended up with this matcher which kind of imitates Rust pattern matching. It's kind of influenced by Rust pattern matching, but it's it has to be a macro, unfortunately.
I have one more stupid question. Do you use Google Test to test Google Test?
Yes, which is as meta as it sounds, and it was fun to get all of the create a building mechanism which would convince Cargo to build the tests, to build separate binaries in test mode, which were actually failing tests, but then not to actually run them as tests and fail. So that was fun, but yes, if you look at the GitHub repository, you'll see some really ugly hacks in there, but yeah.
And I was wondering as well, like, what's the roadmap of the project? Like, you have any important features?
Yeah, good question. We do want to reach 1.0 at some point, but I think at this point we're starting to run out of things to do before 1.0. There are like, I mean, the functionality is already far enough that we're running out of ideas as to what we really want to include before we put out 1.0. But we want it to get more use in the outside world. So we want some more feedback. People say, like, you know, before we reach 1.0, we still have some flexibility about changing the API, which we do a little bit. And once we reach 1.0, then we're committing to the API. And if it turns out that, you know, people start using it and say, this is awful, you know, like, you know, it's impossible to do X, Y, Z. And we realize we can't do that without an API breaking change, then that's kind of unfortunate. So in that sense, we'd like it to get some more use. Eventually, then we'd like to put out 1.0. And as far as features, I don't know of anything major which is still coming, which doesn't depend on Rust RFCs, which still need to be adopted. So yeah, it's pretty much feature complete, I think.
How much usage of that is there inside of Google?
This library, it's starting to find adoption. But it's really new. So it's, I mean, as I mentioned, we only released this to GitHub back in December. And so I'm still getting inquiries like, is it okay to start using this, or is it too early and are we going to regret it? Is it stable? Is it gonna cause my, you know, computer to blow up? You know, I mean, we're getting inquiries like that. But it is starting to find some use.
Okay, so you wrote it as a port first, not driven by internal demand.
Yeah, I mean, it was driven by the demand to have an equivalent to Google Test in the Rust world, more or less.
One last question, maybe.
Yeah. Since you had this slide up for a while now, is there a matcher to work with ranges?
So like between this and
like
that?
Asserts that value in 1.3.
No, I don't have that. And, you know, I mean, it might be reasonable to add. At the moment, one can work with, you know, this kind of thing, like greater than this and less than that. But yeah, I mean, one could imagine also having like a range metric. That's certainly something one can do.
I have one more. Did you consider a different design space, or was it given from the get-go that the Google test and Rust should replicate the usage that people are used from C++? Was that a given, or did you just go down the path because you personally were used to that?
Well, I have never programmed in Google Test because I'm not a C++ developer. So it's definitely not the latter. But it was driven a lot by the desire to make it easy for C++ developers to move into Rust, write tests in Rust, possibly port existing C++ tests in Rust. So that was, in some sense, a constraining factor.
I mean, you don't get all the compile warnings that come with C++ version, right?
It does get rid of a lot of the baggage of Google Test for C++, though. There are a lot of aspects of it which are much cleaner.
Cool. Thank you.
Yeah, thank you.
Our last talk is going to be postponed till next time because it's already 9:30-ish or something. So yeah, feel free to stick around, talk to each other, have another beer, and yeah, thank you for coming.